I'm just finishing up a custom 5/8 inch thick plywood panel that I've made up for the front bulkhead of the tender that I'm building. The plywood is all made up of reclaimed materials. So the core is white cedar from the planking of an old boat, and the skin is Honduras mahogany from the old cabin roof of the same boat. So I know that there are several new viewers to my channel, and I probably should back up a little bit and give a little bit of a background on why I'm building this 9-foot tender. So the tender is going to be for a 38-foot Atkins cutter that my friend Steve Dinette is building on his YouTube channel called Acorn to Arabella. So you certainly can check up here in the corner. If you haven't seen that channel, I encourage you to check it out. Now, one of the questions that I often get is if I'm being paid by Steve to build the boat, and I am not being paid at all to build the boat. He has supplied me with these old recycled materials, but as far as payment for my time, I am not being paid for that. This simply is my contribution to his bigger project. Now, if you'd like to help out on this project yourself, the best way to do that is to become a member of my Patreon account. And there's certainly a link below, and on the end page there also will be a link that you can click. So let me get started with showing you how I built this plywood panel, but first let me show you where it's going to go in the boat. So if we look here at the construction drawing, we can see that there's a bulkhead right here, which is what I'll be making the plywood panel for. And this is going to become a watertight air chamber, a flotation chamber. So then there's also a bulkhead that will be back here, which I'll make a similar type of panel for. And this will be a rear locker. And also it can be a watertight flotation chamber. So the bulkhead will be here at station 2, which you can see I have the station pattern. So I need to have a panel that is 24 inches by 18 inches. So over here at my stack of old cedar planking, which is what I'm going to use for the core of the plywood panel. So what I'm not looking for are boards like this that have a lot of twist and turn to them, but ones like this that are pretty flat and straight. So what I'm going to do first is I'm going to cut this up into 2-foot sections. I was able to get 4 3/16 inch slices out of each board. I've got all of the veneers, 1/8 inch strip veneers, all cut for the first panel that I need. If you remember, the first panel I basically need an 18 by 24. So what I've got are my long strips here are 19, and the short strips are 19 and the long strips are 25. So the way those will go together is these will be the two outer layers, layer 2 and layer 4. So layer 3 will go in here at a 90 degrees like that, and then get glued up. So the next step now is to get the mahogany veneers all processed. So I'm fortunate in that Steve had supplied me with a whole bunch of Honduras mahogany that has tongue and grooved that was on the ceiling of the old Victoria's cabin roof. So as you can imagine, that several of the boards are in pretty good shape, and then others are not as in good a shape. So what I'm going to do is pick out a few boards that I think are pretty decent, and then we'll start cutting them to length. One of the first things I want to do is to go through and inspect the boards to make sure that where they had been nailed, that there isn't a little nail in there so it won't damage my equipment. I'm just going to take a little punch and punch those out of there. So the horizontal strips for the 4 bulkhead need to be 19 inches. So I'm going to cut the first one, 19. So I've got 13 strips cut at 19 inches, so 13 strips easily gives me 26 inches when I only need 25 for my plank. So you can see that this material is, it's a 1/2 inch thick right now. What I want to do are to get some 1/8 inch slices out of there. So my first thought was to resaw them on the bandsaw to see if I could get 3 out of there. Well, once you take 3/8 out of a 1/2 inch, you only have an 1/8 of an inch tolerance, and even the small kerf of the bandsaw still took too much out, especially when you consider that it needed to be put through the surface planer and sand it down to that exact tolerance of 1/8 of an inch. So what I decided to do, because the boards are only 2 inches wide, is that I'll put them through the table saw. I lose a little more with the kerf blade, but it doesn't matter because I can't get 3 out of each board, I can only get 2. So that way I get a nice smooth cut, and then I can then process those through the surface sander and then down to the exact tolerances of the 1/8 of an inch on the surface planer. So let's go over to the table saw and I'll show you the setup I have. So what I have set up here is I have my fence set at 3/16 away from the inside of the blade. Once it cuts 1/8 of an inch out, then that'll leave another 3/16 on this side, cutting it pretty close to being in half. And I've got a feather board set up here so that when I push it in, it's going to keep it nice and tight against the fence. And the other thing that I added was a little block of wood here, because cutting wood like this, especially when the blade is up high, it tends to want to ride up like that. So by putting a little block here, then that'll prevent it from that board from riding up too high. Now I also cut a little groove inside this little block so that the blade can be just a little bit higher than the block actually is when it's going. So we're all set up, so we get ready to cut our first strip. So what I've got here now are 2 pieces. One is the back side, which this is one of the back sides here. And I've got, and here's a front side. So what I need to do next is to surface sand one side of each of these boards. So you can see here on this one, a little bit of the tongue is left over. So from that tongue to the top is probably 1/8 of an inch. And the same thing is true over here, where we have a little bit of the tongue left on there. And you can see here where a little bit of the groove shows. So what I'm going to do is I'm going to sand this backside through the surface sander. So this will be the backside of my plywood that won't show. It'll be on the inside of the bulkhead. And then this finish piece, I'm going to sand the finish side off just in case there's any gouges or things in the surface that I don't want in the finished piece. So that's what I'm going to do next, is to sand those, and then we'll put them through the surface planer so that they'll be exactly 1/8 of an inch thick. Well, I've got all of my 1/8" lifts cut out now, and so I've got them arranged here in that this would be the backs would be layer 1, layer 2, layer 3, layer 4, and layer 5, which will be the outside finished one. So I've got 3 questions now that I need to answer before I start my glue up. The first is how I'm going to keep those lifts and layers all clamped together. So what I started with was I took a piece of plywood, a nice flat piece of plywood, and I covered it with some plastic first. And then I rimmed it with some 1/2" plywood edges around the edge so that it was squared up. That way I'll be able to put those layers in there and they'll hold tight. And then I covered those up with some glue tape so that the glue wouldn't stick to it. So the question now is, how am I going to get those pressed down? Fortunately, I have a piece of plate steel that was used when I would display sculptures temporarily, like on a sidewalk or on a plaza or something like that. So I have a piece of steel that's 3 foot square and 3/4 of an inch thick. So it weighs somewhere around 450 pounds. So that's what I'm going to do next, is I'm going to get out that piece of steel. So the next question is, which type of glue am I going to do to glue it up? And I'm going to use one of the Titebond glues to do that. Now, many of you are probably asking right now, why not epoxy? Well, there's a number of reasons. First of all, epoxy is a lot more expensive. It's toxic, and also it has to cure at a very specific temperature range, which it's the winter right now, so it's very cool in here. The other thing is that it's difficult. You have to mix up a certain amount, and given what I'm going to be working on, I really don't know how much of that I would mix up and have not too much left over and not have to stop and start again. And the other thing is cleanup, is that once that epoxy is cured, cleaning it up is going to be very, very difficult. Now, don't get me wrong, I think epoxy is a wonderful glue, and there's many, many things that it can be used for. It is my opinion, however, that it gets overused in the building of boats. So therefore, I'm going to use one of the Titebond products. Now the question is which one? So the 3 glues that I have here are the Titebond Original, the Premium Titebond 2, and the Ultimate Titebond 3. So Titebond, the original Titebond, is it's a good glue. It is for interior use. Now that's perfectly okay because we'll be coating the entire bulkhead with epoxy, so it will be completely sealed up. The assembly time for this is between 4 and 6 minutes. So it tacks up and sets up pretty quickly. Now, a little better, which is, of course, a waterproof glue, the premium Titebond 2. Now it has a shorter glue up time, actually, only 3 to 5 minutes. And it, as I said, it is a waterproof glue, so it would be a good choice. Unfortunately, it even tacks up faster than the original. And the final one, the Titebond 3, which is considered the best glue. It's also the strongest, which the PSI is about 4,000 PSI for it. It has the longest glue up time, which is between 8 and 10 minutes. And it's also waterproof. So I'm going to eliminate from the choices the original and Titebond 2, the premium. And I'm going to use Titebond 3 mainly because of its longer tack-up time, and that I'll have a lot more time to get the glue and those layers put together. Obviously, it's also waterproof, which is also a plus, and it's the strongest of the three. So that's what I'll be using, is Titebond 3. So my final question then is the squeeze out and the cleanup of the glue. Now, if there's a lot of squeeze out on the back side of the plywood, it's not really a problem because I can easily just sand that off. But my big concern is the squeeze out on the face layer between those two chamfered edges. In this little sample that I glued up, you can see where I have this chamfered edge in here. Now, one thing I did is I had this scraper that has this kind of tip on it that I'd be able to scrape the glue out of there. It was a pretty arduous task to get that done. Now, I have heard that you can use a mixture of acetone, vinegar, and water that will soften already set up glue. I think ultimately the decision that I'm going to make is I'm going to take some blue tape and I'm going to tape each piece right up to that chamfer like so on both sides. So that then the squeeze out will be contained within that groove. Well, it sanded up really nicely, so I trimmed it up on the table saw, and then I did some mechanical sanding on the back, and the glue on the back came off really nicely. And so anyway, I'm pretty pleased with the way it came out. So this will be the 4 bulkhead. So I've got the station mold here, and so all I'll need to do now is to lay that out on there and then trace it out and cut it out. But before I do that, I'm going to go ahead and make the aft bulkhead exactly the same way. So that'll all be coming up in the next episode. So in the meantime, thanks for watching, and remember, if you're going to make it beautiful.